Hi everybody, welcome back to the subject electric power quality. In this video, I would like to explain the concept of waveform distortion. First of all, this waveform distortion, the name itself indicates the entire behavior. There is an distortion in the waveform. This waveform means it is either the voltage or current waveform. Regarding the electric power quality, whatever the power generated at the generating station, it is transferred to the consumer premises. I wish to consider the quantity in terms of an waveform. The true sinusoidal quantity is transferred from generating station to the consumer premises. Whenever there is a distortion in that particular waveform, it is called as waveform distortion. This will be happened because of the disturbances created in our entire power system. At the end of this video, you will be able to explain what is waveform distortion, definition of waveform distortion, 5 main types of waveform distortion. Then coming to the topic, waveform distortions are common power problems that causes equipment to malfunction and sources of power to overload. It is an unexpected change in the waveform of current and voltage as they pass through a device. Observe this slide. For your clear understanding and visualization, I am considering the waveform for the explanation of waveform distortion in a simpler manner. Once observed this waveform is a fundamental pure sine wave. And this waveform is the third harmonic waveform. And here, the combination of fundamental and the pure sine wave plus third harmonic equals or gives rise to harmonically distorted waveform. This is one of the disturbance happened in the circuit. Under the operation, our true sinusoidal waveform is distorted or deviated by this one of the power quality disturbance. Hence, it is defined as waveform distortion is defined as a steady state deviation from an ideal sine wave of power frequency. In this, we are having 5 primary types of waveform distortions: either DC offset, harmonics, interharmonics, notching, noise. According to the DC offset, the presence of a DC voltage or current in an AC power system is termed as DC offset. By observing this waveform, we are considering the time on the x-axis and the voltage on the y-axis, and this particular waveform, it is the composing of the DC components, DC voltage or currents in an AC power system. That's why we will call this one as a DC offset. And the causes of these DC offset, this can occur as a result of geomagnetic disturbance or asymmetry of electronic power converters. Direct current in AC networks can have a detrimental effect by biasing transformer cores so they saturate in normal operation. The effects are: saturate the transformer core, causing additional heating and loss of transformer life. Direct current may also cause the electrolytic erosion of grounding electrodes and other connectors. And the solution for this one is DC filters. And regarding the harmonics, harmonics are sinusoidal voltage or currents having frequencies that are integral multiples of the supply frequency. Observe this waveform clearly, and in this waveform, we are considering the time on the x-axis and the amplitude on the y-axis, and these waveforms are representation here as the one is the fundamental waveform. This particular one is the color representations, observe clearly. This one is the fundamental waveform, and this particular one, there is the third harmonic. This one is the third harmonic, and the fifth harmonic, seventh harmonic, and the resultant of the composing of all these parameters in your system, and this one is the resultant. This particular one is the resultant. The sources are nonlinear loads, and the total harmonic distortion is used to measure the effective value of harmonic distortion. The third one, that is the interharmonics. Regarding these interharmonics, voltages are currents having frequency components that are not integer multiples of the frequency at which the supply system is designed to operate. For 50 Hz or 60 Hz are called interharmonics, and the sources for these interharmonics are static frequency converters, cycloconverters, induction furnace, and arcing devices. Power line carrier signals can also be considered as interharmonics. And for the interharmonics and the harmonics, the effects are overheating conductors and transformers, decreases efficiency, increases losses. And solution for this one, in order to reduction of these quantities, that is the power conditioners and the harmonic filters. And the notching is a periodic voltage disturbance caused by a normal operation of power electronic devices when current is commutated from one phase to the another. By clearly observing this one, it will entirely explains this notching. The true sinusoidal quantity is going to be disturbed here. That means we are observing some of the notchings presented here. Some of the disturbance is presented here. And this one is observed by the consideration of these power electronic devices. The causes are three-phase power electronic converters, and the effects regarding injects harmonic into the supply. Solutions in order to reduce this one, that is isolation of sensitive devices. And regarding the noise is the unwanted electrical signals with broadband spectral content lower than 200 kHz superimposed upon the power system voltage or current in phase conductors are found on neutral conductors or signal lines. While observing these particular waveform, it will entirely shows the noise behavior, that is the superimposition on the power system, this broadband spectral content, that is which is lower than 200 kHz, that superimposition is this one, this particular one, superimposition of these communication lines, broadband spectral content. We are considering the time on the x-axis and the voltage on the y-axis, and this is the true sinusoidal waveform, and this true sinusoidal at this region, this one is disturbed. The distortion is occurred, this true sinusoidal waveform, because of the broadband spectral content lower than 200 kHz. This is called noise. And the noise regarding the sources are power electronic devices, control circuits, arcing equipment, loads with solid state rectifiers, and switching power supplies. The problem can be mitigated by using filters, isolation transformers, and line conductors. Thank you.